We studied that many scientists tried to systematically arrange the elements, mainly in the form of a table. However, have you ever heard of Dmitri Mendeleev? Well, Dmitri Mendeleev was a Russian chemist and professor who wrote the name of every element on separate cards, along with their properties. He then sorted and resorted the cards in rows and columns until they fell into a pattern. He took all the then known elements and prepared their oxides and hydrides. Based on those oxides and hydrides, he found the valency of each element. He arranged the elements in a table such that, while going from one element to the next, there is an increase in the atomic weight, and every eighth element is a repetition of the first element in the table. Later in his research paper, titled, "The Dependence Between the Properties of the Atomic Weights of the Elements," which he presented at the Russian Chemical Society, he wrote the periodic law according to which the properties of the elements are a periodic function of their atomic weights. So, what was his periodic table about? Let us have a look at Mendeleev's periodic table. We observe that 1. There are 8 vertical columns, which are called groups, and 7 horizontal rows, which are called periods. 2. The first 7 groups had 2 subgroups each, and the properties of elements in each subgroup were the same. 3. Mendeleev said the elements in a group had the same valency. What were the merits of Mendeleev's periodic table? The merits of Mendeleev's periodic table are: 1. All the then known elements were placed in the periodic table. 2. The periodicity of the elements was a periodic function of the increasing atomic weight. 3. Mendeleev left gaps for elements that were yet to be discovered. For example, Mendeleev left a gap below aluminium and below silicon. 4. He predicted the properties of those undiscovered elements, for which he left gaps in the periodic table. He named the element below Al and below Si, for which he left the gap, aluminium and silicon respectively. However, there were demerits to Mendeleev's periodic table as well. The demerits were: 1. He grouped a few dissimilar elements together. For example, copper and silver were placed in subgroup 1b, but placing them in group 1, along with subgroup 1a, was not correct, because sodium, potassium, rubidium etc. showed no similarity in the properties with Cu, Ag, etc. 2. A few similar elements were separately placed in Mendeleev's periodic table. For example, gold and platinum were placed very far from each other, even though their properties were like each other. 3. His table did not have separate positions for isotopes. 4. Mendeleev violated his own rule. For example, cobalt is placed before nickel, but cobalt has more atomic weight than nickel. Co, Ni, and Te, I, etc. were called anomalous pairs. 5. Mendeleev's periodic table did not have a place for the noble gases. The modern, or the long form of the periodic table, that we refer to today draws the maximum inspiration from Mendeleev's periodic table itself. We will study the same in another video. Contemporary to Dmitri Mendeleev, there was a German chemist named Lothar Meyer, who also showed the repetition in the physical and the chemical properties of elements based on their increasing atomic weights. However, he put his data in the form of a graph. Mendeleev's paper was much more celebrated than that of Lothar Meyer. One probable reason for such a happening might be the prediction of elements and their properties that were yet to be discovered. Dmitri Mendeleev received the Davy Medal from the Royal Society of London. He was nominated for the Nobel Prize initially, but later, the nomination for the same got cancelled. However, there are institutes named after him in Europe and in Russia. The biggest gratitude towards Mendeleev was in the form of naming an element after his name. The element was mendelevium.